Hello students, welcome. Previously, from 4 topic 4, lesson 3, we were dealing with electrochemical cells. Today, lesson 4, we are going to proceed to standard electrode potentials. So let us start by defining what standard electrode potential is, and we are saying this is the potential difference of a cell comprising a particular element in contact with 1 molar solution of this ion and the standard hydrogen electrode. So next we are saying the chosen electrode is hydrogen and is usually referred to as the standard hydrogen half cell. So being the reference electrode, it is assigned an electrode potential of 0.00 volts. So next, the standard conditions for measuring electrode potentials are 3. Number 1, temperature of 25 degrees Celsius. Number 2, or Romeo 2, pressure of 1 atmosphere. Then Romeo 3, we are told all solutions have a concentration of 1 moles per liter, or a molarity of 1 mole. Then next we are saying platinum electrode is used as the electrode when the half cell does not include a metal, e.g. the hydrogen half cell. So what is the function of the platinum? We are saying the platinum electrode has 3 functions. The first one, it acts as an inert metal connection to the hydrogen system, or to the hydrogen half cell. Number 2, it provides a service on which dissociation of hydrogen molecules can take place, that is, hydrogen gas losing electron or dissociating or ionizing to form hydrogen ion and also 2 electrons. Number 3, it serves an electrical conductor to the external circuit. Then lastly, we are saying the standard electrode potentials are sometimes referred to as the standard reduction potentials or standard redox potentials because they relate to the reduction reactions. Okay, let us see how the hydrogen half cell look like. The hydrogen half cell looks like this. We are having the platinum electrode, and this is the solution of 1 molar hydrogen ion, and this is hydrogen gas bubbles around here, and the condition for that is hydrogen gas at 25 degrees Celsius. That's the condition for temperature, which is 25 degrees Celsius. Pressure of 1 atmosphere, pressure of 1 atmospheres. And we're saying all solutions have a concentration of 1 molar per liter. Even that hydrogen ions, they are having 1 mole as their concentration. Next, we are supposed to see the standard reduction potential. This is the series, the standard electrode potential series. We are starting here the most positive, that's fluorine, up to lithium, which is the most negative. Remember, we said these standard electrode potentials are sometimes referred to as the standard reduction potentials because they relate to the reduction reactions. Check, all these reactions are just reduction reactions because we say reduction reactions, or reduction is gain of electrons, and when we are gaining electrons are added or are written on the reactant side, and the standard electrode potential is arranged so that the strongest oxidizing agent like fluorine here, the strongest oxidizing agent like fluorine, which has the most positive value, that's positive 2.87, is placed at the top of the list, where the weakest oxidizing agent here, the weakest oxidizing agent like lithium with the most negative, that's negative 3.04, is placed at the bottom of the series. So remember, the strongest reducing agent is also known as the weakest. The strongest oxidizing agent is also known as the weakest reducing agent, whereas the weakest oxidizing agent is known as the strongest reducing agent. You have to know also those terms. Next, let's go to the uses of the standard electrode potentials. We are saying standard electrode potentials are used in Romeo A, comparing the oxidizing and the reducing powers of substances, but B, determining the EMF of a cell, the electromotive force of a cell, but C, we are saying predicting whether a reaction will take place or not. So let's start with the first use of standard electrode potential, which is comparing the oxidizing and the reducing powers of substances. So here we are going to start with saying the more the negative the standard electropotential value, the stronger the reducing power of that substance. If we check from the table, the one that's negative, we're saying the more the negative the standard electropotential value, the ones that are negative are from here, lead with negative 0.13 volts up to negative 3.04 in the side of lithium. So we're saying the more the positive, the more the negative the standard electropotential, the stronger the reducing power. So therefore we're saying from the table below, lithium with standard electropotential of negative 3.04 volts has the highest tendency to lose electrons, and therefore it is the strongest reducing agent. So here, what is strongest reducing agent? We are talking about reducing agent. The other name for reducing agent is oxidation. What is oxidation? We said oxidation is loss of electron. So the ones that loses the highest tendency, or the one that's having the highest tendency to lose electron, it is the one that's going to have the most oxidation. That means the strongest reducing agent. So we're saying from the table below, lithium will be the one that's having the strongest reducing agent because it is the most positive, or it has the most negative standard electron potential value. So if you compare maybe the reducing power of maybe zinc and also aluminum, we are going to check their standard electron potential. The one that's having the most negative will be the one that's the strongest reducing agent. So remember, the one that's the most reducing agent, it is the weakest oxidizing agent. So we are saying lithium has the least tendency to accept electrons or to gain electrons, hence it is the weakest oxidizing agent. So that means the one that's the strongest reducing agents takes the weakest oxidizing agents. You have to know that. Okay, next let's talk about the ones that are having positive values. So we are told the more positive the standard electropotential value, the stronger the oxidizing power. So if we check from the table that we are given in the standard electropotential series, we are having the positive values from hydrogen all the way to fluorine, and the one that's having the most positive is fluorine with the electropotential of positive 2.87 volts. So we are saying the more the positive the standard electropotential value, the stronger the oxidizing power. So we are saying oxidizing power, that means the strongest oxidizing agent. That's what we are talking about. So what are oxidizing agents? So oxidizing agents take the word reduction. So what's reduction? Gain of electrons, or the ones that accept electrons. So the one that's having the highest tendency to accept or to gain electron will be the one that undergoes a lot of reduction or undergoes the most reduction. That means it will be the strongest oxidizing agent. So we're saying fluorine with the standard electropotential of positive 2.87 volts has the highest tendency to accept electrons, and therefore it is the strongest oxidizing agent. So in contrast to that, we are saying the one that are the strongest oxidizing agent will be the weakest reducing agent, because we are saying fluorine has the least tendency to lose electron, hence it is the weakest reducing agent.